Hello everyone. So today this question is a really interesting to me. Not only just interesting, but also it has multiple ways to solve it. If you are, for example, you have learned a bit about multivariable calculus a bit. So um, let's try to do this for some minutes and we will go back to solve this question. Okay. Um, so this question is a bit tricky because when you draw the diagram, you will find lots of problems and you will get a really wrong answer. So you need to follow the logic a bit about this question. So you need to find AB. This is a point on the ellipse, the ellipse, which is this one. We name it as E. And then we have a point AB in the first quadrant. So first quadrant means it exists in this region. So we just focus on this region. We try to draw them. We try to name any point, like let's say this one here. So this area is enclosed by the lines y equals to x, and then y equals to b, and then x equals to a. You have a x equals to a, which is this one, this line. You can just basically draw vertically along the parallel to the y-axis, and then also y equals to b, where I can just draw it like so. Sorry, doesn't matter to me. Okay, now and then one more thing is the y equals to x line, which is 45 degrees to this one. So you have a area, which is I'm gonna use the blue one, which is enclosed by y equals to x, which is this one, and then this one is called y equals to b, and then this is called y equals to x equals to a. So these lines, these three lines, 1, 2, and 3, they have an area of a, which is at here, and the area must be maximum. Okay, area maximum. So are you sure that this blue region is maximum? How about we consider this point here, this point, and then you draw again the lines of B. In this case, we're gonna draw it across here, and then we're gonna draw it across a bit there. So you might have seen the fact that it's more than just, well, it's more than just you think. As you can see, you have a y equals to x here, which is this line, and then also this y equals to b, and also x equals to a. So these are the lines responsible for the area. I mean primarily this one, and this one. And then since this question states that it's in the first quadrant, we must be also responsible for this line. This line must also be responsible for the area. So it results actually in this green area, which includes the blue one, and then you will get a maximum area. So it's very important to choose between 2 points. So one of the points is just on the right hand side of the y equals to x, and the other point is just at the right hand side, on the right hand side of the y equals to x. You must choose carefully between this point and also this point. So obviously P2, which is this one, gives larger area than the P1. And so this implies that we must consider any point which lies on the right hand side of y equals to x, which is somewhere here. Okay, somewhere here. So we're gonna think about this case. So we have to find, we don't have to find the area, the green area, but we just have to find the AB. So how about we try to think about a bit about coordinate geometry. So we know that this point is A comma B, and this is, because this is x equals to A, so this is also A, so I can use a blue one. You will get, just black. I'll just use A comma 0, and then here you will have, in this case, 0, 0. And then here, this is a line y equals to b. It passes through this y equals to x. So this is a point of intersection between y equals to x and y equals to b. And so this point is definitely b comma b. So we have 4 points. 4 points means we can use these four points to find the area of the trapezium. Alternatively, you can actually just use the area of trapezium by finding this height and then the side lengths. But in this case, because I want to use the coordinate geometry method, which is easier, so we can use the coordinate geometry method to just do it, just to get the area of the trapezium. So 0, 0, and then you can choose in any direction. In this case, I want to choose anti-clockwise. So A0, AB, and then BB equals to the area A, which is the maximum area. So I use capital A. And then I will have 1 over 2 here, but I don't have to, you don't have to move a constant all the time just to get rid of the fraction, because we need to focus on the area A. So we just maintain the position of the A. We don't have to get any coefficients beside the A. So we just 1 over 2, and then absolute value. In this case, we assume that the absolute value inside the entire thing is positive. So using the formula, the shoelace formula or whatsoever, we can get this one. And then b squared. Then inside there is positive. It doesn't matter. So you have here 2ab minus b squared, and then over 2 equals to a. So this is a function, the area function, which depends on variables a, b, where a, b are the points on the right hand side of the y equals to x. And one more thing, which is a very important, which we want, is a constraint. So what can you relate with the constraint, with the term constraint? Yes, we have to deal with a multivariable calculus, and yes, we have to do something which is called as the Lagrange multiplier theorem. So we can use this one as a constraint. So we know that A is a point on the x-axis, so x equals to A, and then B equals to the point, well, the value on the y-axis, which is this one. And so we can just substitute y with B. And so we can get 4a squared plus 3b squared equals to 12. And then we have our second constraint. So we can just create a constraint by having this difference between these two functions. So we can create this second constraint, namely f ab equals to 4a squared plus 3b squared minus 12. And you have two functions, first and second. Yes, according to our rule of thumb, excuse me, we can have actually two functions to solve two variables. But in this case, it's not about solving like simultaneous equation, but we have to use the Lagrange multiplier method, which has to do with the multivariable calculus, a bit advanced, to solve for A and B, which the values of a and b gives you the maximum value of a. Okay, the particular value of a and b. So we need to use a Lagrange multiplier theorem, and we need to find the first and foremost, we have to differentiate in respect to a. So let's say I lambda on f. So a equals to the lambda f a, or you can just get nabla a in respect to a equals to lambda nabla f in respect to a, and then you will get, well, in this case, just differentiate in respect to a, and then you will get here b. Okay, because if you just try to separate this fraction, you will get ab minus b squared over 2. Differentiating it, you result in b only, because b squared over 2 is a constant. Okay, remember when you deal with a multivariable, just like a lesson that we have done. And then equals to that constraint. So lambda must be included. You will have only 8a in this case. And then we nabla again in respect to b equals to lambda nabla in respect to b. You will have here, so we have here a, then minus b equals to the lambda times, in this case, because in respect to b, we have 6b here. So, yeah, which is in this case better. And so, allow me to do some bits of a calculation here. So, okay, it's okay. Now we continue our steps. So we have two functions, and these two equations. First equation will be this one, and then the second equation will be this one. We're gonna eliminate the lambda. Since lambda doesn't play any important role, we just have to find the particular value of a and b. So one of the methods I will suggest you to do is to focus on the ratio of AB, because, well, if you want to eliminate lambda, you have to divide the equation 1 by equation 2. So you will get, in this case, well, on the right hand side, you will have the lambda cancelled, and 8a divided by 6b, and then equals to b, this one, over the a minus b. And I want to make it I want to inverse it on the both sides, okay, by raising it power by -1, and I will get 6b over 8a equals to a minus b over b. And as you can see, you have a ratio of ab and then ba here because of the fraction. And so, and at the same time, I can simplify this into 3, 4, and then you will get 3 over 4 times b over a equals to a over b minus 1. So we name the ratio of a over b equals to t. And then we can get this one as 1 over t, and then this one as t minus 1. And then you will have the end, which is 3 times 3 equals to the 4t squared minus 4 in this case, right? And then you will have 0 equals to 40 squared, sorry, it should be 4t, minus 4t, and then minus 3. Yep, and then you can just factorize them out, resulting in this thing. Well. So, well, yep. So you can get t as the ratio which is equivalent to 3/2, or you have a T2 equals to -1/2. So logically, okay, which one is the correct ratio? We have only one ratio because we need to find a particular value, pairs of values A and B. So we need to have one ratio because this ratio is denotes the ratio of A to B. So you might have correctly guessed this one is the correct ratio, while this one is the wrong one. Why? Because T2 is a negative ratio, and we can't have a negative ratio in the first quadrant because first quadrant must have the positive values for A and B. And so T1 is the correct ratio. So we must use T1 equals to 3/2. So 3/2 equals to, in this case, A over B. And hence, we can get, well, we can just use this. And we try to substitute B 2/3A. And then you will get the third equation. And then substitute this third equation into the constraint, which is this one. So I copy this back. So I have here, which turns into 4A squared plus 3 times 2/3A squared equals to 12. And then when you calculate it, you will have these as a 4/9 A squared equals to 12. Then you will have 12/9, and then 4A squared here. So you will have here 4/3. And then you will have here A squared equals to 12. Then you will have 12 plus 4, then over 3, A squared equals to 12. And hence, you can get, well, in this case, A squared equals to 9/4. And then A equals to 3/2. So it must be 3/2 because it is in the first quadrant, so it must be positive. And then the second one, which is for B, we just substitute A equals to 3/2, and then you will get this equation. And hence you will have, in this case, 3B squared equals to 3, if not mistaken. Yes, and then B equals to 1, which is the value for B. So we have two answers. We have two values for A and B. So A comma B is a coordinate. It equals to 3/2, 1. AB is also the point which lies on the ellipse, which gives the maximum area with the boundaries, with the line of boundaries between y equals to b, x equals to a, and also the line y equals to x. So I will recap back what we have done. So first and foremost, we have chosen the correct point, which is the P2, which gives you the maximum area. As you can see, P1 can only give you the blue area, the minimum, and P2 can only give you the maximum area. And then you can just use the coordinate geometry to find the area of the green trapezium. You will get the left one, the red one, A bracket A comma B, and then which is equal to AB minus B squared over 2. And then FAB equals to the constraint. We must have a constraint by having by having the FA comma B equals to the difference between the functions here and there. So you can just carry out the Lagrange multiplier theorem. Well, just apply it, and then you will get these equations, E1 and E2. By eliminating the lambda, you will get a special equation. It's called a ratio equation. So we denote that A over B equals to T. We solve for T, obtaining that one of the ratios must be correct, which is the 3 over 2. And then 3 over 2 equals to the A over B. And then B equals to the 2/3 of the A. And then substituting the value of B in terms of A, you will get the value of A equals to 3 over 2. And hence the value of B equals to 1. Well, apart from solving the ratio T, you can just also use the elimination. Just after you dividing the E1 by E2, you can just carry out cross multiply from this step, and then you will get something like this. This is just for additional information if some people they are stubborn enough to think about eliminating fractions. So you can cross multiply it, you will get this one, and then you can just try to get something like this, and then AB, and then notice that 4AB equals to 4A squared minus 3B squared. As you can see, this has something to do with your constraint a bit, because your constraint is 4 squared plus 4A squared plus 3B squared equals to 12, which is this one. So 12 equals to this one. So you can just eliminate by adding these two things up. This one, add with this one. You will get 4AB plus 12 equals to 8A squared. And then you can just solve for A like a quadratic equation. You will get 8A squared minus 4AB minus 12 equals to 0. And then 2A squared minus AB minus 3 equals to 0. Solving like quadratic equation, you will get here, in this case, B plus minus B squared plus 24 over 4. So you just have to consider which value of A is correct. Which one? You have two. One of them is when you have plus, and then the another one is when you have minus. So just substitute one of them. So you will get, for example, I try for having the plus. So you have 4A and then minus B equals to, in this case, this one. So yeah, you have to solve it again, making a new kind of equation. You will get 16A squared and then plus B squared and then minus 8AB and then equals to B squared plus 24, and then you will get 16A. My apologies. I don't know what happened. And then minus 24 equals to 0. And as you can see, you will be able to solve for A by using back this quadratic equation. Okay, well, I just have to move this one here. Okay, I just have to move this one. As you can see, just a similar thing. So how it can be similar? Because when you just compare this quadratic equation with the another one, they are just same. So yeah, which shows that the value of A when the square is positive, it must be correct. You could also try using the -1 and then try to form it back to have a same quadratic equation. But at the end, it doesn't matter because you have two types of A and B. So you can just use one of the values of A in terms of B, which is this one. And then you can just try to substitute these things entirely into the constraint, which is this one. And then you will get the value of b. And then you will get then the value of a by substituting the value of b into this constraint again. And then you will eventually get that a equals to 3 over 2 and then b equals to 1. So that's why I don't really suggest you to use this quadratic method, because so don't cross multiply first. You could have actually just think about the fact that fraction can be a ratio, can be expressed as a ratio if you have only these two variables in your equation, which are fractional in this case. So hopefully you could have learned something new, especially the solving techniques, not just because of learning the Lagrange multiplier theorem. Hopefully you have studied well in maths, and see you next time.